off, we're going to have a New York local. He's going to be going over scaling, but Kirill has been with the community for over a decade now, all the way from the ages of Magento 1.2. So really impressive to see somebody with that sort of tenure. So happy to introduce Kirill.
Thanks a lot. Thanks a lot. So I'm Kirill Morozov, and I've been around the block for a while, and we're gonna talk about scale. So, and in previous series with pushing Kubernetes out, I've been out to deliver the great performance and scalability for Magento for a while. So I'm putting more stuff into Kubernetes cluster, and we're dealing with processing at scale at this time. So more and more processing, which is scaling for products, catalogs, customers, orders. We need millions of products in our catalog, and that's what we're scaling for, scaling the processes. So in brief, this talk is going to be about internals of databases, internals of Magento currently, and streams, which we can leverage, then shift to consuming the Debezium part, change data capture itself, and finalize with deduplication, which is going to be fun. So let's go about database internals. So we know our databases is pretty simple. We just write them, save stuff. We know what transaction is. Everything gets written into so-called binary log. So binary log is necessary because originally databases were built for consistency. Even if those fail or restart, reboot, we need consistent input and solid performance. So MySQL, MariaDB perform pretty much the same internally in terms of storing data. So besides that, those binary logs of databases of all the records ever changed are consumed by replicas, which we use for scaling read activities. So we have more traffic coming, we have more reads. In order to serve more customers, serve more, we produce more replicas and use the binary log to move data from master instance that we write to replica instance. And that would be one of cornerstones for our build-up. So let's talk about what we currently have in terms of our processes that we wish to scale. Let's go with simple. Product grid updates. We are just updating those grids. That's another cron job, picking up. We are running insert from select. Yes, locking a bit, probably not as much. We can do it slightly better. So let's move forward with another one. We're dealing with typical indexer, which does put stuff into changelog table, and changelog table is painful. Who worked with it? Who loves it? Okay, so that's another thing that's gonna work much better. So we know it. Sending emails, that's another fun piece. Asynchronous sending of emails puts the blob of stuff into the email table, like for orders, invoices, shipments, and so on. And then another cron job picks it up. That's pretty much the same. So some people use relays that take right away the message to be sent. Some people don't yet. So, and there is a lot of fun going what's the current state and why it's not going faster in terms of we got that update in database and we still have some time to process it, which is slow. So in order to deal with slow and making it faster, people started using queues. So we're dealing with queues, which is pretty simple concept. we have known Magento for having queues for a while, starting with RabbitMQ. So, and queue tables in database, which is probably there are right now much better tools to use. So let's talk about queues a bit. So there are queues, and currently those evolved into streams. So the difference between queues and streams is that streams can be consumed multiple times, and they are storage. While queues, you consumed it once, no one else will consume it. That's pretty much main difference. So we have RabbitMQ, we have SQS in Amazon, we have recently released queue from Bloomberg, we have well-known Kafka, we have Redis Streams in our stack, and RabbitMQ streams just got out recently. So why picking Redis streams for this particular case? Because it's on our stack. We've been with Redis for a while. So Redis was in production since 2013. Since then evolved, got upgraded, received those queues. So the only downside I see so far for our current build is to have only one CPU per thread, because the name of the queue defines where it will be stored. If we're using Redis cluster, we're looking at most one CPU per queue. So, moreover, if we would build it right away, yet another observer putting data into regular Redis queue, that's boring. And then deal with handling out of that Redis queue with concurrent or not concurrent reads, which is possibly okay. So let's get to the next level and capture our change straight to the database. I've been roaming around various meetups here in the city, and I found that this picture is quite common as a build-up. So you have database, and you have Debezium, and you have streams of data and pushing into outer areas for processing. So what does it actually do? Debezium takes that binary log and moves it into the queue, into the stream for further processing. So that's the cornerstone. So we are gonna take this one, swap out Kafka with Redis streams. Debezium was originally built for Kafka. We don't have to use it in particular. So let's have it working. So we're gonna push data right to database right away. We don't need any other confirmation for end user, so which gives us a bit of a benefit on communication side with the customer or who else is there. And then we have that stream of data, all the changes, insert, updates, deletes, and those are getting pushed forward to our processor. So what actually Debezium does, it's pretty much creates a stream for every table with information that flows through. So the previous setup slightly gets more complicated. We're getting change data capture, pushing data from our favorite tables, catalog product entity, decimals, varchars, and so on. So we are taking MySQL binary log, Debezium does it for us, pushing into the stream. So in order to set up that Debezium, we need a user with replication permissions for MySQL or Maria, whichever you're using. We actually need the target, destination, configuration, and the container. So let's go in brief in terms of setup for Debezium for change data capture. So it's straightforward, pretty simple. What's our source and what we are reading out, and which connections we are using. So it's simple. Which tables we're getting, which tables we're not. Debezium has extra pieces for snapshotting and schema changes, so we may even use it to replicate data from production to staging live right away, if it goes for a catalog or some other piece, or replicate to another database, partially filtered, live changes that are masking personal data. So we don't need changes for snapshotting right now. We don't need changes for schema changes. And we're dealing with the destination format and the destination. In our case, it's going to be Redis. So if you wish to use, Debezium provides two types of encoding, which is going to be compact and extended. Extended one is great if you wish to look at it within IDE, what's going on out there. Let's get to probably the most fun part of deduplication. So we're getting real-time streams of data from multiple tables, and we need only once to push it to whatever, Elasticsearch or flush cache in a certain period of time. We don't need all the changes right away. We want to have that particular deduplicated piece, because we know our Magento database writing a lot of stuff when we are saving something, some product, for example. So we're going to go with requirements. We need instant update, some deduplication window, and we need to, after deduplication, we want to go right away into processing. So without any whatsoever delay. So how it might look like. So we're dealing with concurrent reading, and we're pushing into concurrent other streams that are gonna do deduplication. So we have constraints. So what are our constraints? Can we do it with PHP? Really? Someone? Guess? No. Why? Because we want runtime. Runtime, we want it to run indefinitely. That service which does deduplication, we want to have it working indefinitely, because it's stream gonna be incoming indefinitely. So with JavaScript, with Node.js, we can do something of that, but we're locked down due to shared memory model. We're locked down to a single core, single thread. That's a constraint. I was forced to, but I was forced to use Java. And 10 years ago, it was not that great. And back when I was at eBay, there was choice not to go with Java, with Magento whatsoever. But times have changed a bit. So with recent Java advancements, there are immutable records and stream processing. Moreover, Spring Boot, yet another framework around the corner, just keep the frame. And main component is Reactor, which allows us to define concurrent application in a way that doesn't feel concurrent. So we don't deal much about concurrency there. We're defining those pipelines, and those will run concurrently on all the cores if we define those parallel. So that's the change of mindset. And the functional pieces of programming, and that approach basically helps to define those chain of promises, like with Node.js, if you open up the code, you will see it's not too much different. So I've built up a tool which consumes those Redis streams, and here's simple configuration for it. We have the source, we have buffers, we have target, and we have, it's a bit truncated for specific tables which were coming from, deduplicating from. But it's pretty much it. Its purpose to run deduplication for a time frame and certain size. If we're, in this particular case, getting beyond 100,000 records changed in database in 5 seconds, then we're gonna take deduplicate that piece and put the chunks of unique ones in batches of thousands, like indexers like to currently, updating those pieces. So let's look into a bit of implementation, how concurrency is handled. So we have first message 0 incoming on a different thread from 1, 2, and 3. So those 3 messages, each of those has a duplicate coming up next. So for that one, concurrently, we're pushing those duplicates into acknowledgement internal stream processing in memory, and effectively doing countdown for, do we need to acknowledge it, if it's safe to acknowledge it. Then actually pushing information into the our destination for non-duplicate ones, and then proceed with acknowledgement of all of those, including duplicates. So that racing situation gets resolved when we want to acknowledge change. So that's it, and it means we're utilizing cores, 1 core for read, 1 core for write, for every stream. And that goes just well. Yes, we need to consume those. For that one, the basic processor on a PHP side to run indefinitely, you can keep it, let it run, let it die, and Kubernetes will rerun it again. You can have several. Due to the nature that in the stream we have deduplicated unique items, they won't fight for the same resources in terms of updating those target destinations. So in terms of processors, we may use something more advanced. Llama 3.1 generating descriptions. Even more advanced Llama 3.2 to generate descriptions for images that we just pushed. So that can go straight to the processor, that information of uniqueness. So we have a bunch of orders coming in during checkout. The duplicator will take care of those, and we will get 1 item to update quantity for, or rolled up. We can have that with change data capture. So what are overall benefits of deduplication and all the outcomes we're getting? So we're getting lighter transactions when we're not writing into changelog tables at all. Nobody fights for adding 1 more row. We are getting data stored consistently on a disk. That's great. For business, we're getting instant updates. Within 30 seconds, we can have changes up to date. Yes, with large backing up queues, we might get some delay. But we're still getting that in single-threaded situation. But in this case, we're still getting a benefit of capability to run concurrently multiple processors of deduplicated items. So let's move forward for us, for engineers. We have consistent stream, persistent data. We can reread it over and over again. So in terms of coding, that's just great for us. We are perfectly suited to repeat, rerun tests, and so on. So that's pretty much our piece. In terms of code, here's the code. On the GitHub, both for service, for a container to launch, Java itself implementation, and respectively indexer. Feel free to hit me up on LinkedIn. There was first slide there with LinkedIn profile. You can also find me in Magento Slack, Cloud Native Foundation Slack, what else? ClickHouse Slack, AI Camp Slack, quite a few. And that's pretty much it. In terms of, I'm ready for questions.
All right. Thank you, Kirill. So we have time for 3 questions here. So any questions?
Was it too much? Yeah, that topic in general was considered advanced back in eBay Magento times. Swapping out and using Red Hat, originally I believe implemented Debezium. That was a fun topic back then. Given we can deploy those in Kubernetes workloads pretty easily, that's going to be just fine. So we deploy that container, it sucks in data straight from database. If we have whatever machine learning pipeline, we can connect it straight to our streams outcome. We can swap with RabbitMQ streams, Redis, possibly. That's not a big deal. And that's the whole concept. Who wishes to kill indexers?
Is the main point of all this complexity to avoid database locks?
To scale. If you wish to scale, you
Right.
need to avoid locks. If you are avoiding locks, you can scale.
Yeah. Okay.
And it is actually not as much complexity. It felt complex back in 2012, 2013. But with that Debezium container, you have it right away. And complexity comes with deduplication. And deduplication is not an easy one, either way. So that's the part. So I'm giving out that deduplication component, so the pipeline can be whole. So if you're pushing out updates to CRM, which is rate limited, you still have those updates of customers in the stream incoming, and you have those rate limited updates into CRM. And that keeps that bridge of unique versus not unique. And the deduplication window is essential for that. Because a lot of things happen upon order placement.
That's an understatement.
Anything else? Please? Was it too much?
No, I think scaling is always on everybody's mind and always ever present with Magento and Commerce, so I think that's great. Last chance for Kirill. All right, otherwise, give him a round of hand.
Yeah.
And a couple minutes until our next speaker.
Yep.